Inequalities are used a lot in math, and as you're going to be using them most often, they're going to start making their way into you discussing what domains and ranges of functions are. And that's going to be the primary usage you're going to have for them. I mean, at the high school level, they would often give you a lot of problems that kind of forced a less than or a greater than in there. However, in a lot of those cases, it didn't matter so much, or you wouldn't be dealing with a situation like that in reality. So, oftentimes students were left with just answering questions that didn't really, weren't, how questions would normally be answered in the real world. But the fact of the matter is, I mean, where we use inequalities a lot or when we start describing domains and ranges. So looking at these inequalities here, first, z is greater than -4. If you know your symbols, a direct translation would be z is greater than -4. So knowing that this is the greater than symbol, if it's facing the other way, the open is facing the other way, it's the less than symbol. Just make sure you know the difference between the two. On a number line, that means that you'd start ever so close to -4, but not at -4, just anything that's even slightly over it, hence an open circle, and anything to the right of that would be considered part of that inequality. So that's what the graph would look like. Set notation is basically not much different than writing the inequality, except you're going to see some set brackets around it, and either a vertical bar, which is one that I most often see in textbooks, which means such that, or as your textbook uses, they'll use a colon here just to say that z and z is defined by. So whether you have a vertical bar here or a colon doesn't matter. It's just that it's essentially you're just adding fancier looking brackets around it, another reference to the variable, and either a colon or a vertical line. After that, it's just the same old inequality as before. So inequalities tend to be used more frequently in this textbook than set notation. Interval notation is important to note because of the fact that you're going to see that a lot in a lot of calculus books. And interval notation more or less looks like what you see on the number line. So at -4, you get infinitely close to it, but you don't touch it, which would mean that you're going to see an open parenthesis at -4, then it goes on forever or to infinity to the right. And you see another open parenthesis here, which indicates that, well, you can't equal infinity. You can't reach infinity, so you cannot never actually be that amount. So make sure there's never a square bracket on infinity, because that's basically saying that you've reached infinity somehow. So here, x lies between -7 and 5 inclusive. You might see that wordage. There are some textbooks that sometimes if they say between -7 and 5, that includes -7 and 5, and there's other textbooks that'll say that that you wouldn't include them unless you're told that. In mathematics, it usually is the second one. You don't include them unless you're told, and usually you're going to see the word inclusive if that's what it means. So that's why it's in parentheses. It really depends on the textbook and the author as to what they mean by in between something. So here it's just being specific and saying it is inclusive. And when you start getting things that are like between or dealing with two quantities, where the variable is, it is actually easier to look at the number line first to get an idea of what you're talking about. And so you have -7 and 5. X can be those two values, and of course anything in between them as well. So as far as an inequality goes, the simplified form of that inequality, you would just say that -7 is less than or equal to x, which is less than or equal to 5. So you see the x's between them, and including those two endpoints. And of course, the set notation would be very similar, just the set brackets, another reference to the variable, either a vertical bar or colon as your book has it, and of course writing the same inequality again. In interval notation, you're going to have a bracket for -7, comma 5 bracket. It means you're going from -7 to 5, including those two values. Again, it's kind of describing what you see on the number line above there. Y is less than 8 or greater than or equal to 15. Again, to have a better idea of what this would look like on a number line, you'll help us graph it a little bit better and state what these other things are. So an open circle at 8 because I'm less than it but not equal to it. And of course less than would be to the left. Or it could be 15, actually equaling 15 or more. And so you're seeing this graph here. And so as far as writing it as an inequality, you would say that y is less than 8 or y is greater than or equal to 15. That or statement's important. There are some cases, if you remember from algebra, you may have taken cases like this, and this was an and statement. This could have been written as x is greater than or equal to -7 and x is less than or equal to 5. But most often and statements are written in their in-between kind of format. So this is considered a more simplified version than this, but it's the same statement. Whereas an or statement, you are pointing in two different directions, so you can't really combine them together to make one all-reaching inequality. So, of course, the set notation would be the fancy set brackets, reference to y in either a vertical line or a colon, and the same inequality you have above there. And of course here, you're going from 8 down to infinity, not including the 8, so down forever, or negative infinity. So open parenthesis, comma, 8, close parenthesis. This union symbol is the same thing as saying or. So this is where the or is coming into place. You have 15, which are actually equal to that because you can equal 15, and then you go on to infinity for that. Yeah, an open parenthesis because you cannot equal infinity. And so those are the ways that you're going to see oftentimes how inequalities are represented. In this course, you're going to see mostly the inequality. The number line is always a good idea to keep in mind because interval notation is a big one that they want you to know and focus on. And so they want you to be able to know what it looks like on the number line, and the interval notation is what you're going to be using a lot of in calculus. So that's the end of this example.